So today we begin Unit 3. This is going to be on Lesson 1 on customary measurement. This is going to be Chapter 4, Sections 1 through 5. To start with, we're going to work with, as I said, customary measurement, but also as we move through these, we'll talk about metric conversion. With metrics, most of us really aren't really familiar with the units of measurement with metric system, much less conversions. Then we'll talk about time and temperature. And then we also have to be able to move between customary and metrics as well. So that's kind of what we're ahead in these lessons as we move forward. So I may break this up in a couple of videos as we move forward. So as we begin with customary unit of measurement, that's basically what we call U.S. customary. Basically, the United States are the ones that use this, but since the United States is one of the more powerful countries in the world, other countries have to adapt to our units of measurement as well. But vice versa, since we do business with the rest of the world, we have to adapt to the metric system as well. So we have to learn actually 2 units of measurement as we move forward. So the first thing we're going to mention is units of length or distance. These are the ones we're probably most familiar with, is that 12 inches is a foot, 36 inches is a yard. Maybe that might not be as common, but 3 foot is a yard. We may know that one. And 5,028 feet is equal to 1 mile. We may have came across that somewhere in our classes, but we probably have not really applied that in the real world. Some other symbols to point out though is notice how 8 inches can be written 2 different ways. We can use what's like the quote notation or the IN. And also that quote goes with seconds as well. 60 seconds is equal to that, or spell it out. The symbol for feet kind of looks like an apostrophe. So 3 feet equals 3 feet. Those are interchangeable. And that also is a minute symbol. 60 minutes equals 60 minutes. Those are interchangeable. So when it comes to weight and mass, sometimes we use these interchangeably. In engineering and science, though, it's more about mass. It's the quantity of material that makes up an object. The weight is the measure of something with respect to Earth's gravitational pull. So the most common ones in the US are ounces, pounds, and tons. So we should be familiar with that 16 ounces is a pound. I was a meat cutter back at Briar Patch today, so I kind of had that aspect because of cutting meat. Or if you're at the grocery store, a lot of times if you're buying ground beef, that's about the most common places I come across it myself, is 16 ounces is a pound. And 2,000 pounds is equal to 1 ton. That's another one that we may be familiar to as far as, loading capacity of trucks and things like that. The other thing we have is what's called capacity or volume. Capacity or volume, it could be both a liquid or a dry measure. But most common here in America, dry measure is usually going to be represented in ounces and pounds. Liquid measure is more of what these units will be used for. So if we look down at our little table, if I'm measuring liquids out, teaspoons and tablespoons, ounces and cups, pints, quarts, those are, and then of course the gallon is the big one that we have as far as capacity goes. And I do use these for liquid and dry measure a lot of times, especially in cooking. I'll see these. For kids in elementary schools, they learned a lot of this using what's called gallon man. So what we do is we draw a big old G, and kind of it becomes the head of this person. So inside of the gallon man, we have 4 Qs. So we have 1 Q, 2 Q, 3 Q, 4 Qs. So what we pick up on is 4 quarts is equal to 1 gallon. The next thing we pick up on is there's 2 Ps inside of each cube. That means there's 2 pints per quart. So this visual is very powerful. I used this a little bit when I was teaching the GED, and I still remember it now. It's very powerful. And then each P has 2 C's attached to it. So each P has 2 C's attached to it. And if you Google gallon man, you'll actually see images of something probably a little bit more artistic than this, but you can see some images of gallon man if you Google it. It's such a thing, believe it or not. So gallon man, this big old G. So from this, I can see a lot of relationships. I can see that there's 2 pints in a quart, there's 2 cups in a pint, but also what I pick up on, there's 2, 4, 6, 8 pints in a gallon. There's 4 cups in a quart, or there's 1 group of 4. There's 16 cups in a gallon. So there's a lot of little interactions there with gallon man that we can pick up on. So that's something I picked up on with liquid measurement. Now, as we move forward, we're going to be talking about what's called a unit ratio. A unit ratio represents a value of 1. So remember, a ratio is a fraction concept. So what we can pick up on is, as long as the numerator and denominator have the same value, they represent 1. So if I look at ounces and pounds, I can write a unit ratio with ounces to pounds. So if we put 1 pound on the top, 16 ounces on the bottom, what I pick up on is these have the same value. 1 pound and 16 ounces are equivalent. So this represents a value of 1. Also could have put 16 ounces on the top and the 1 pound on the bottom, and that would also be the same thing as 1. So that's called a unit ratio, a ratio that represents 1. So as long as the numerator and denominator are equivalent, that will always represent 1. So cups and pints, notice how there's 2 cups per pint. So 2 C's per 1 pint. I think they use PT for pint. Or you could have had it as 1 pint over 2 C's. That's where the table comes in handy as well. See these abbreviations up here. Little t for teaspoon, big T for tablespoon. And these are quite universal. Most things are using that as a representation. So when changing from one customary unit to another, one of the things I like to use is what's called a unit ratio. So if I want to find the number of inches in 5 feet, so how many inches is equal to 5 feet? What we do is we start with the given unit of measure, which is the 5 feet. And what I want to do is I want to multiply it by a unit ratio. The catch is, since I'm converting to inches, the inches has got to be in the numerator and the feet's got to be in the denominator. And like I said, since we have the same unit in the numerator and denominator, they will actually divide out, and that will leave me my inches. But in my ratio, this has got to be a unit ratio. So we know that there's 12 inches per 1 foot. So we end up multiplying. And again, to make this look like ratios or fractions, I could put the 5 feet over 1. So our strategy says the original measure is going to be in the numerator and with a 1 in the denominator. So I'm going to put the original one 5 feet over 1. And what I'm going to do is I'm going to multiply it by a fraction that's a unit ratio. And remember, whatever I begin with, that feet, that's got to be the unit in the denominator of the unit ratio, because they want to divide out. And then I'm actually able to multiply this across. 5 times 12 is 60. 1 times 1 is 1, but if 1 is in the denominator, we don't have to write it. So this becomes then 60 inches. How many pints are in 4.5 quarts? So to do this conversion, we start with the 4.5 quarts. And we put that over 1 to make it a fraction because we're going to multiply by unit ratio. Now, pints and quarts, again, I can use either gallon man or our table. Notice how it says 2 pints per quart, or we see that there's 2 P's in a Q, 2 pints in a quart. So notice that when I might write my unit ratio, what I'm starting with, the quarts has got to be the denominator of my second fraction or my unit ratio, which means the pint's got to be in the top. So remember, there were 2 pints per 1 quart. And notice the key is the quarts are going to divide out. So this becomes then 4.5 times 2, which would be 9. 1 times 1 is 1. And if 1's in the denominator, we don't have to write it. So this becomes then 9 pints. So how many inches are in 2 1/3 yards? One way to do this again is write down the 2 1/3 yards. Notice how it's important to keep the units in this. And we will multiply by the unit ratio. Now, there's a couple ways of doing this. One way is see if we can find a relationship between inches and yards. So in our table, we pick up on that there are 36 inches in 1 yard. So the yard can go on the bottom and the inches can go on the top. And to make that a unit ratio, so again, to make my unit ratio, I have 36 inches per 1 yard. So again, I can make this first ratio, first unit, I can put that over 1 to create this fraction times a fraction concept. So the goal is, all I really got to do is multiply 2 1/3 times 36. Now keep in mind, the 2 1/3 can be changed to 7/3. So I can multiply this to 7/3 times 36. Or I can put that 36 over 1. And also how I can divide out 3 goes in 36 12 times, and 7 times 12 would be 84. So this would be 84 inches. Now you also could use your calculator and just times 2 1/3 times 36. So if I hit the alpha F1 button, notice number 2 creates this mixed number format. So I can put 2 times this 1/3. And then I can multiply that by 36. That will give me this 84 as an answer. Now, something else we can do is you may recognize that yards is more, as far as common knowledge, yards ties more closely to feet, and feet ties more closely to inches. So I actually could use a multi-step problem on this. So if I have a multi-step problem, what's important is just focus on one aspect of the problem at a time. So if we focus on just the units of measure, yards to feet, notice how the yards and the yards on the bottom and feet on the top. And then I go feet to inches, feet's on the bottom, inches. Notice how that thing leaves me with inches is my thing. And then all I got to do is put the numbers in there. And then I can just kind of focus this all out here. So not like I said, if we have yards, we can multiply by the unit ratio where I know that yards goes with feet. And then I can multiply by the unit ratio where I know that feet goes with inches. But notice how the units have to be on top and bottom to divide out, top and bottom divide out, and that leaves me with inches. So we have, again, the 7/3 yards at the beginning, and we're going to be multiplying by 3 feet per 1 yard, and we know there's 12 inches per 1 foot. So really all we're doing is doing 7/3 times 3 over 1 times 12 over 1. Notice how the 3's divide out, and we just have 7 times 12, which will give us then this 84. 84 inches would be our answer. So that's another way to do it, is try not to do it all together, but just focus on the units of measure and then bring the numbers into play, and then you can focus on the numbers. Now, another way to do this is use what we call conversion factors. So these unit ratios, what we can do is change these unit ratios to decimals where necessary. So to create what we call conversion factors, these unit ratios can be expressed in either a whole number form or a decimal form. So if I want to develop two conversion factors relating pounds and ounces, well, we know that there is 1 pound for every 16 ounces. So that's how we have this 1 over 16. I can actually change 1/16 to a decimal. So 1 divided by 16 gives me 0.0625. So it's going to be 0.0625. If I do the other one, we have 16 ounces per 1 pound. That's just going to be 16 over 1, which is just going to be 16. Now, notice how the ounces is on the bottom here. So that means we had to start with ounces. So if I'm going from smaller to bigger, what we pick up on is we're going to have to multiply by a decimal conversion factor. Notice how if the pounds is on the bottom, that means I had to start with pounds. So in other words, if I'm going from bigger to smaller, big to small, I'm going to be using the 16. So what we discover is it's easier to go from big to small because my conversion factor is going to be a lot simpler. So these are some of the conversion factors you'll see. Notice how feet to inches. So notice how that's big to small. Notice how it's a nice, easy conversion factor. Meanwhile, if I'm going like feet to miles, notice how I'm going from small to big. Notice how it's a crazy decimal conversion factor. So it's easier to convert from big to small rather than from small to big, but sometimes we have to do what we have to do. So if I want to convert 56 ounces to pounds, notice how that's small to big. Small to big, that means we'll probably have to be using the decimal conversion. So ounces to pounds, notice how we have our conversion factor is going to be 0.0625. So if I want to convert 56 ounces to pounds, that's going to be 56 times 0.0625. And that would give us our answer by just simply multiplying by the conversion factor. So it gives us 3.5. So that would end up being then 3.5 pounds. So like I said, big to small, easy. Small to big, not so much. So like I said, if you're going small, big, small, notice how you're going to use the decimal. Because your decimal is going to be like the small number. If you're going big, small, you have to use big. Kind of alternates big, small, big number, which means we get to use a lot of times the whole number conversion. Easy peasy. So another thing we have is what's called standard notation. Standard notation is going to be a little bit different. So some of this doesn't work really nicely on a calculator. We have to do a little bit of this math on our own. And this kind of math actually involves a little bit of long division. Not too hard, but a little bit different. So standard notation, what they're asking is like if I have 8 pounds and this 20 ounces, I always want to not make a space there for some reason. You need to make a really nice space between your number and your unit of measurement. So 8 pounds, and then we have 20 ounces. 8 pounds, 20 ounces. To be in standard notation, if a bigger unit can be pulled out of a smaller unit, we want to do that. And since there's 16 ounces in a pound, we know we could pull out a bigger unit out of the smaller unit. So we do the 16 into 20 using division. we get 16 goes into 20 one time. 1 times 16 gives me a remainder of 4. So what that tells me is I can write the 20 ounces as 1 pound and 4 ounces. So this gets written as, instead of saying 8 pounds plus 20 ounces, this gets written as 8 pounds, and the 20 ounces can change to 1 pound plus another 4 ounces. So what happens is the like units can be put together. This becomes then 9 pounds, and then this 4 ounces. And that's how we can just drop the plus sign in standard notation. So it means 9 pounds plus 4 ounces. And again, the next thing for pounds would be like tons. Well, I would have to have 2,000 pounds to make a ton. Well, we don't have enough of that. So the 9 pounds has to stay as is. So it becomes then 9 pounds and 4 ounces. That would be what's called standard notation. So if I have 1 gallon and 5 quarts, what I'm trying to do is pull out a larger unit out of the smaller unit. So the 5 quarts is what we pay attention to. Well, how many quarts are in a gallon? Well, remember there was 4 Q's in a G. That means there's 4 quarts per gallon. So what I got to do is I got to divide the 4 into the 5. Well, 4 goes to 5 one time, and we get a remainder of 1. So that tells me I can pull a gallon out of the 5 quarts. So this becomes then 1 gallon, and then the 5 quarts changes to 1 gallon plus 1 quart. And then we can put the like units together and say there's 2 gallons and a quart. And that's what's called standard notation. Again, gallons is the largest unit of liquid, so that stays as is. So next one is we have 2 yards, 4 feet, and 16 inches. So again, we start with the smallest unit, and we want to see how many feet we can pull out of it. Since there's 12 inches in a foot, what we're trying to do is figure out how many feet we can pull out of that 16 inches. Again, this can be done mentally. You don't have to be using long division if you can see it. So I can pull out 1 foot, and 16 minus 12 would be 4. So this 2 yards and this 4 feet and the 16 inches now turns into 1 foot and 4 inches. So I can add my like units together. This now becomes 2 yards plus 5 feet plus 4 inches. And then we're at our 5 feet. Remember, since there's 3 feet in a yard, I can pull out a yard out of that. So if we do 3 into 5, we're going to see 1 goes into there, and I get a remainder of 2. So 3 goes to 5 one time with 2 left over. So this turns into 2 yards, and then the 5 feet turns into 1 yard, and we have 2 feet left over, plus the 4 inches comes along for the ride. So I'm going to make this math go away. It's kind of supposed to be scratch work somewhere, or you could do it mentally. So then notice how the like units are the yards there. So I have then 3 yards and 2 feet and 4 inches. So if the smaller unit can be converted up to the next larger unit, you need to do that to be what's called standard notation. So 3 yards, 2 feet, and 4 inches would be the correct way of writing that. So to add, unlike U.S. customary measures, catch here is to add unlike customary measures, you got to convert one into the other, and then we can add them together. So if we have 3 feet plus 2 inches, notice how we can't add those together because they're not the same unit of measure. So if we want to add these actually together, they have to be in the same unit. And also how it's easier to convert bigger to smaller. So I could change the 3 feet into inches. So bigger to smaller is actually easier way of doing it. So we can say 3 feet. And remember, if I use the unit ratio, that's going to be, remember the feet's got to be on the top bottom and the top's got to be the 12 inches. So like I said, if you're going from bigger to smaller, that means we got to be multiplied by the conversion factor, which is the 12. So this becomes in 36 inches. And we may have already knew that just by looking at it. So if I have 36 inches, I can now add that to the 2 inches, and that becomes 38 inches. And that's how we can actually add, unlike units, is put them in the same unit and then add them together. Now, if we're asked to change that into standard notation, we would have to do that. But most often, I don't think they actually ask us to write that as standard notation. But if they do, then that would not be the final answer. So to add mixed US customary measures. So if I gave you like standard notation stuff here, if I give you 6 pounds, again, I need to put a space there between the number and the unit measure so it doesn't look like a 61. So if I have 6 pounds and 7 ounces, the easiest way to add these together is just write a 6 ounce plus 7 ounces. And what you're going to do is you're going to add 3 pounds and 13 ounces. So you can add like units to like units. So it's going to give me 20 ounces, and then you're going to have 9 pounds and 20 ounces. But notice how this has to be in standard notation if there's mixed measures. So if it's mixed measures, standard notation, we have to change the, that 20 ounces doesn't quite look like I wrote that right. Looks like I need 20 and a space there with an OZ. So notice how the 20 ounces has to be converted because we know there's 16 ounces in a pound. So I can pull out the larger unit out of the smaller unit. So 16 goes to 21 time with the remainder of 4. So this becomes then 9 pounds, and then the 20 ounces becomes 1 pound and 4 ounces. So this becomes then 10 pounds and 4 ounces in standard notation. So if you have mixed measures, they want you to kind of leave that in mixed measures. So if I want to do subtraction, if I have 15 inches from 2 feet, notice from 2 feet means I'm actually starting with the 2 feet. So that's got to be 2 feet minus then 15 inches. Notice how they're not like measures. But I can change 2 feet to the smaller measure because remember, it's easier to go from big to small in this case. So it turns into like there's 12 inches per foot. So if I multiply the 2 times the 12, 24 inches becomes that. So 24 inches, take away the 15 inches, becomes then 9 inches. So that would work that way. Now, if I have mixed units like this, notice how it says from 7 pounds, 8 ounces. So I'm starting with the 7 pounds, 8 ounces plus the 8 ounces. And I'm subtracting 3 pounds, and I am subtracting 12 ounces. So subtracting the 3 pounds and the 12 ounces. So you're subtracting both of those values. But notice how I can't do 8 minus 12. So here we have a borrowing concept. So if I borrow a pound, that makes that 6 pounds. But when I bring the 1 pound over here, it's got to turn actually into ounces. And since it's 16 ounces per pound, that turns over to its equivalent of 16 ounces. So this problem turns into 6 pounds plus 24 ounces. And then we're going to be subtracting 3 pounds, and we're going to be subtracting 12 ounces. So this gives us then 12 ounces and 3 pounds. And notice how 12 ounces, there's not enough ounces to make it a pound. I can't go up to the next bigger unit because I need at least 16 ounces to make that happen. So that is in standard notation as we look at it.